Assalamualaikum dear students, how are you? I hope you all are fine. Students, in our previous lecture we have discussed how to add or subtract the rational numbers, and today we have also done activity related to that task. Today we will revise how to multiply the rational numbers and how can we divide the rational numbers. To multiply the rational numbers, we simply multiply numerator with numerator and denominator with denominator and convert into its simplest form. Other method is that before multiplication you can simplify into their lowest form, or the numbers uh, divided by the same numbers can be cut down. Okay, one numerator and one denominator will be cut with the same number. Okay, after this you can multiply and divide the rational numbers. Okay, next one is multiplicative inverse. How can we find the multiplicative inverse of the word or a fraction by which we can multiply the our fraction and we get the answer 1? That is called the multiplicative inverse. Okay, like there is a fraction p over q, then the inverse of their fraction is q over p, because if we cut it or simplify it will get answer 1. Okay, so the simply we if we want to find the multiplicative inverse, we simply just take the reciprocal of the fraction. Okay, and in division, if there is a division in between two rational numbers, then we will take the reciprocal of the second fraction and then we solve it according to the method of multiplication. Okay, but I have a video for you so that you will be able to understand these concepts. Okay, so let's start the video.
In this video, we'll talk about the steps for multiplying and dividing fractions, as well as a property of real numbers that explains why the steps that we take to divide fractions will always work and give us the correct answer. So to begin, let's multiply these two fractions, 1/2 times 3/4. So in the real number system, we have two operations, multiplication and addition. And what we do for those operations is define what those are. So the reason that we know that 1/2 times 3/4 equals whatever the answer is because we've defined what multiplication means. So for fractions, the definition of multiplication is to multiply the numerators together and also to multiply the denominators together. Right, so to multiply these two fractions, I would do 1 times 3, which is 3, and 2 times 4, which is 8. And that's it. This fraction is in lowest terms. There is no number which can be divided into 3 and 8, so I know that this is a fully simplified fraction. Here's another example. If you're asked to multiply -3/4 times 2/9, you would multiply the numerators, -3 times 2, to get -6, and you would multiply the denominators, 4 times 9, to get 36. And then notice this one is not in lowest terms. Okay, -6 and 36 can both be reduced by the number 6. Right, so I can rewrite this as -1 times 6 and 6 times 6, and then use the identity property to cancel out these 6's because 6 over 6 equals 1. And then my fraction equals -1/6. Right. Now you've probably also been taught that you are allowed to cancel at any step here, at any stage. So if in this original problem you happen to notice that a numerator and a denominator, the 2 and the 4, could both be divided by 2, it's okay to do that division at the beginning. Right, so divide 2 by 2 to get 1, and 4 by 2 to get 1, or I'm sorry, to get 2. And then if you also happen to notice that the -3 and the 9 can both be reduced by 3, it's okay to do that then as well. So -3 divided by 3 is -1, and 9 divided by 3 is 3. And then from there I would continue on with my multiplying, and we would now do -1/2 times 1/3, and then do the same thing. -1 times 1 is -1, and 2 times 3 is 6. Alright, and that's the same answer there. one more example of multiplying fractions, 2/5 times 6. And notice that 6 could be written as a fraction because it is a rational number. We could write this as 6 over 1, and then we just use our rules for multiplying fractions. So 2 times 6 is 12, 5 times 1 is 5. All right? And you probably weren't asked for a decimal in an example like this, so if you are just asked to multiply two fractions and leave your answer in lowest terms, 12/5 would be your final answer. All right, how about dividing fractions? So division isn't one of our operations in the real number system, so we define division based on the definition of multiplication. So for fractions, here's how this works. To do a division problem, we rewrite this as multiplication. So we would rewrite this as 2/3 times, and then we rewrite the second fraction and we replace it with its reciprocal. So I would write this now as multiplying by 6/5. All right, and we'll talk in a couple of minutes about why that works, why we're allowed to do that. But for now, we just want to learn the steps. So to divide two fractions, multiply by the reciprocal. Okay, and then from there, this is just a multiplication problem. 2 times 6 is 12. 3 times 5 is 15. And if you didn't reduce at this step with the 3 and the 6, you would now need to do that. Okay, so 12 can be divided by 3. That gives us 4. And 15 can be divided by 3. And that gives us 5. So your answer is 4/5. All right, here's another example. 3/5 divided by 3/2. Okay, so to divide fractions, you leave the first fraction, change it to a multiplication problem, and then change the second fraction to its reciprocal. So the reciprocal of 3/2 is the fraction that you get when you just flip the numerator and denominator, so that would be a 2/3. All right, and then at this step, I'm just going to do the canceling now. I can use the identity property to reduce these 3's because 3 divided by 3 is 1. And then that saves me a lot of time in the end here because those are just going to be 1's now. And now my final answer would be 1 times 2, or 2, and 5 times 1, or 5. Okay? Same thing, divide the fractions. So again, notice 6 is really 6 over 1. And if you rewrite it like that, it's a little easier to see what the reciprocal is. So negative 2/5 times, and then the reciprocal of 6 would be 1/6. Okay? And that's negative 2. Negative 2 times 1. 5 times 6 is 30. And that can be reduced, divide the numerator by 2 and the denominator by 2. And you get negative 1 and 15. So the answer is negative 1/15. Okay, let's talk about why this works. So we know that to divide 1/3 divided by 4/5, we would change this to 1/3 times 5/4, and let's talk about why. Okay, so first of all, I'm going to write this as a complex fraction, which just means a fraction divided by another fraction, and I write it as a huge fraction with fractions in the numerator and denominator. Okay, so next, let's use the identity property. I know that I'm allowed to multiply this by 1, right, or anything that equals 1. So I'm going to choose to multiply this by, right, and you'll see why in a minute, I'm going to choose 5/4 over 5/4. Okay, and that does equal 1 because the numerator and denominator are the same. Anything divided by itself will equal 1. Okay. If you're not convinced, you could enter that into a calculator, 5/4 divided by 5/4, and convince yourself that that's 1. Alright, so now to multiply these fractions, we just follow our rules for multiplying fractions. Okay, and in the numerator, right, so for this giant fraction, I'm supposed to multiply this numerator and these denominators. Alright, so the numerator I'm actually going to leave, and again you'll see why in a minute. 1/3 times 5/4. But I am going to do the denominator, 4/5 times 5/4. Alright, so notice the 4's will cancel and the 5's will cancel. Okay, and that actually just gives me a 1. And if I divide 1/3 times 5/4 by 1, that just equals 1/3 times 5/4. It doesn't change the answer. Alright, so I started with my original division problem, 1/3 times 4/5. That's this one on the left. And then I went through all of these steps, and really all I did, the only change that I made, was to multiply both of these fractions by the number 1. Okay, so that's the identity property of multiplication that tells us that we can do that, and that the answer, or in this case the problem, does not change. Right? And then I went through all of the rest of these steps and ended up with this multiplication problem. So I've showed that these two problems are the same using the identity property of multiplication. Alright, let's try it with one more example. Show that 2/5 divided by 7 equals 2/5 times 1/7. Alright, so I'll rewrite this. This is 2/5 divided by 7. Right, and then using the identity property, I'm going to multiply this by 1. And I'm just going to choose to do 1/7 over 1/7 because I can see where I'd like to end up. I'd like to use the reciprocal of this 7 so that my denominator will cancel out and just be a 1. Alright, so in the numerator, I could work that out and get an answer, but I'm just going to leave it as the multiplication problem. Right, 2/5 times 1/7. Okay, so that takes care of this part. And then in the denominator, right, I've got 7 over 1 times 1 over 7. Alright, so 7 times 1, that's 7. And 7 times 1 in the denominator, that's 7. Okay, 7/7 is just 1. And dividing by 1 leaves you with the numerator 2/5 times 1/7. Alright, so I started with the division problem, multiplied by 1, which does not change the division problem, and ended up being able to express it as a multiplication problem.
Okay students, now I hope you have understand these concepts, how to multiply and divide the rational numbers. Now it is your task to simplify question number 3 from exercise number 2.2 so that you will understand it clearly and you will revise the method discussed in the video. Okay students, take care. Allah Hafiz.